This morning we have a report that the object got much brighter than expected, and moreover, the color of the object is bluer than the sun. And that's very surprising, because usually when there is dust around an object, it should make it red.
Coronagraph systems stationed across cislunar space are recording a chromatic shift of an unprecedented nature. The interstellar object, designated 3I Atlas, has exhibited a quantifiable change in color, shifting from green bioluminescent emissions to a vibrant blue radiation signature as it made its closest approach to the sun. This dramatic shift in wavelength points to thermal conditions that actually surpass the temperatures of the sun's photosphere, which itself burns at 5,800 degrees Kelvin. Maintaining a surface hotter than our sun is an extraordinary challenge. In fact, an object at the same distance as 3I Atlas should theoretically be at least 20 times cooler. Therefore, it ought to appear redder, a phenomenon that defies all known precedents in the history of cometary observation, as current astrophysical models predict the exact opposite chromatic behavior. Typically, objects drawing near a star are expected to display red-shifted spectral profiles, because their particulate matter scatters shorter blue wavelengths, while allowing longer red frequencies to pass through. And yet, data from multiple coronagraph platforms conclusively shows 3I Atlas is now radiating predominantly in the blue spectral bands. This strongly suggests an internal energy source is generating heat that exceeds the 5,800 Kelvin baseline temperature of the sun's own surface. Harvard astrophysicist Avi Loeb has officially designated this color anomaly as the 10th major observational inconsistency, prompting him to pose a critical research question. Is it possible this interstellar visitor utilizes active thermal management systems that operate at temperatures far beyond those of natural stellar processes? My goal is to gather as much evidence as possible, making it impossible for the scientific community to simply sweep these anomalies under the rug of conventional thinking. That is my core motivation, you see. And so, I am actively sparking a debate on this very topic. There is enormous interest in this debate, which will drive us to collect as much data as we can, so that when all is said and done, we'll figure out exactly what this cosmic visitor is. Let's consider the fundamental challenge this poses to physics. Standard thermal radiation is governed by Wien's displacement law, which states that higher temperatures yield shorter wavelength emissions, appearing blue. Conversely, lower temperatures are supposed to generate longer wavelength emissions, which appear red. For 3I Atlas to shift from green bioluminescence to a blue thermal signature, all while being bombarded by intense solar radiation, represents a complete reversal of all expected patterns of heat dissipation. An object's mass determines how much heat it can hold from its formation, while its surface area dictates the speed at which it can cool off. On October 29, 2025, the object made its closest approach to the sun, where it was subjected to a thermal load of 7,170 watts per square meter. A perfect geometric alignment placed the visitor directly behind the solar disk from our perspective on Earth, hiding it from view, since its conjunction on October 21st. This entire transition was documented by 3 space-based coronagraph systems. The Stereo A spacecraft's Core 2 platform captured data during the approach phase from its leading orbital position ahead of Earth, while SOHO's LASCO instrument suite, positioned at the Sun-Earth Lagrange point L1, provided uninterrupted observation. Additionally, the GOES 19's Core 1 instrument, which was deployed in 2024, successfully resolved fine-scale structural details of the object. A collective analysis of this data reveals a systematic departure from all predicted cometary behavior. The laws of physics dictate that comets should look redder as they near the sun, because Rayleigh scattering redirects blue light while allowing red light to travel forward. Furthermore, cometary temperatures typically remain orders of magnitude below those of the photosphere, meaning they should only be generating infrared and red emissions, and certainly not blue. So, Dr. Loeb, you previously rated the likelihood at 4 out of 10. Has that number changed regarding the possibility that this is intelligent life and not just a massive rock hurtling through our solar system?
I believe
that with this new evidence of a blue color, my assessment is now slightly above 4. Observations back in August showed 3I Atlas with the expected green and red coloration. This new perihelion data represents a fundamental break from that, as the coronagraph imagery clearly shows a distinct dominance of the blue spectrum. According to Dr. Loeb's own technical analysis, this chromatic shift is an exceptionally surprising discovery, one that fundamentally challenges our conventional understanding of how a natural object should behave thermally. Now, it's crucial to understand the implications of this temperature signature. Dr. Loeb's analytical framework leads to one decisive question. Is this object utilizing an internal energy source to generate thermal outputs that actually exceed the surface temperature of our own sun? If this is confirmed, it means we are documenting a form of technology capable of sustained thermal management far beyond stellar photosphere conditions, a capability that transcends anything within the realm of current human engineering by several orders of magnitude. The fact that 3I Atlas is showing a dominant blue spectrum while passing through the solar corona points to some form of active energy generation, which would be necessary to maintain temperatures exceeding 5,800 Kelvin. Data from our coronagraphs reveals a glowing envelope stretching out for roughly 300,000 kilometers, a distance nearly matching the radius of the moon's orbit around Earth. This observation lines up perfectly with the massive plume of carbon dioxide that was detected back in August. Furthermore, new measurements show its brightness is increasing at a rate that far surpasses typical comets from the Oort cloud. Research teams are openly admitting that the mechanisms behind this are a complete mystery. Simply put, no existing framework in physics can account for what we are observing. At this very moment, a global network of radio observatories is keeping a constant watch, monitoring it for any electromagnetic signals. These arrays are meticulously scanning for any structured transmissions, unusual infrared signatures that might indicate a propulsion system, unexpected changes in its trajectory, or even the deployment of smaller reconnaissance probes. In a significant move, congressional oversight committees are now working to declassify high-resolution images from the October 2nd observations, which could unveil structural details that have not been released to the public. And what you are about to learn is that this strange behavior is just the latest piece in a much larger puzzle, a pattern of events so statistically improbable they demand our attention. This marks the 10th major anomaly in an already extensive list. First, its trajectory is aligned within 5 degrees of the ecliptic plane, an occurrence with a mere 0.2% probability. Second, during July and August, it ejected material toward the sun, which is the exact opposite of every other comet ever documented. Third, spectroscopic analysis of its composition shows a high ratio of nickel to iron, a signature that more closely resembles manufactured terrestrial alloys than natural cosmic materials. Fourth, it is approaching from the very same coordinates in the sky as the famous 1977 WOW signal. 2 separate events, 48 years apart, pointing to the exact same origin point in space. Fifth, it is extremely dry, containing only 4% water, compared to the typical 80 to 90% found in comets. Sixth, its color has made a chromatic transition from green to blue. Then, there are the thermal emissions. When you calculate the combined probability of all these anomalies, the odds are less than 1 in 10 quadrillion, which is comparable to winning a major lottery 15 consecutive times. But what most people watching might miss is what the upcoming December observations could reveal. On December 19th, 2025, 3I Atlas will make its closest approach to Earth. The James Webb Space Telescope will be gathering direct spectroscopic data, while the Hubble will be tasked with capturing high-resolution analysis of its structure. At the same time, dozens of facilities worldwide are coordinating the most intensive observation campaign ever mounted for an interstellar visitor. Current models suggest the object will emerge with even greater luminosity. It is possible its blue signature will become even more intense. Astronomer Avi Loeb emphasizes that acquiring the maximum amount of data is absolutely critical. He states the implication of alien technology would be enormous, and therefore we must take this possibility seriously. If 3I Atlas is truly incorporating technology that generates a thermal output exceeding the temperature of stars, then the level of engineering required would transcend anything within our current human development frameworks. Thermal signatures reveal an object's energy budget architecture, and natural objects operate passively, absorbing solar radiation and then re-emitting it at cooler temperatures, which produces redshifted profiles. An active object generating its own internal energy, however, could exhibit a blue-shifted signature if its processes operate at levels above the solar photosphere. This distinction is what fundamentally separates natural phenomena from technological systems. No other interstellar visitor has ever shown this combination of characteristics. Oumuamua, for instance, demonstrated non-gravitational acceleration but had no visible outgassing. The comet Borisov, on the other hand, appeared entirely conventional. 3I Atlas, however, exhibits patterns that range from highly anomalous to physically contradictory, all culminating in this signature. What makes this unprecedented is that we are observing it in real time, as conventional models fail to accommodate the data. This object is currently transiting our solar system, perfectly positioned within the reach of our most sophisticated detection infrastructure. And it is exhibiting characteristics that demand explanations which do not yet exist. The global scientific community has mobilized comprehensive resources, and space agencies are coordinating data-sharing protocols. Military and civilian systems are synchronizing their detection efforts, as professional researchers and citizen scientists collaborate on the most significant identification effort in observational history. We are left with three analytical frameworks. First, we could be witnessing unknown natural physics, which would mean our current models contain fundamental gaps. The second possibility is an extreme statistical edge case, where multiple low-probability factors have converged at once. The third, and most profound theory, is a technological origin, suggesting we're documenting manufactured systems from an extrasolar civilization. While an extreme statistical event would prove how much we have yet to learn, a technological origin would finally answer humanity's oldest existential question. That anomalous blue signature continues to appear in the coronagraph data streams, with the STEREOA spacecraft tracking 3I Atlas as it emerges from perihelion. The SOHO Observatory is tracking every fluctuation, while GOES-19 captures the data in unprecedented resolution. Embedded within that data is an answer that will fundamentally alter our understanding of either physics or our very place in the cosmos. December will bring clarity. Until then, you are witnessing scientific history being made in real time, one anomalous blue photon at a time. The implications for future space observation, infrastructure investment, and the protocols for detecting interstellar objects could prove to be completely transformative for the entire aerospace research and technology sector.